Alright, so welcome to 7.2, Chapter 7.2. This is the first chapter, or sorry, the first video for Chapter 7.2, or Section 7.2. We're going to talk about 7.2a, multiplication of rational expressions. So we're going to talk about multiplication of rational expressions, and that's what we're going to do today. So we're going to take a look at multiplication. The entire section talks about multiplication and division of, hang on a second, multiplication and division of rational expressions. But we're going to talk about multiplication just today in this section, 7.2a. So we're going to take a little step back and say, I guess, what do we do with rational numbers? In order to multiply rational numbers, basically what we did is we multiplied the numerators and we multiply the denominators, and then we factor things out, and then we can factor the numerators, factor the denominators, and then cancel factors. And remember that when we look to simplify after we multiply the two numerators and the two denominators, or several numerators and several denominators, then we look to cancel. And remember that when we cancel, there's something to add to your study guide. We have to cancel factors. And remember that factors are things that multiply together. So we're going to factor things out later on. We're going to factor numerators, we're going to factor denominators, and then look to cancel factors. And remember that factors are things that multiply together. So let's take a look at maybe a definition of what we've got for polynomials. Multiplying polynomials. If I've got p over q, which is a rational expression, p and q and r and s are all polynomials. If I've got p over q times r over s, these are all again polynomials, then that is equal to the numerators multiplied together. P times r over here is p r, and q times s is qs. Now it's not going to be as simple as that, because we're going to have some things that p might be something that we have to factor out, r is something that we might have to factor out, and then look to cancel factors from p and q and r and q and p and s and r and s. So we'll have to look to do something like that. But essentially this is what we're doing when we multiply polynomials. If we're multiplying polynomials, we take our numerators, multiply those together, take our denominators and multiply those together, and then look to cancel or factor things out. So let's take a look at maybe some examples. We're going to take a look at, I guess, these simpler examples, and then move to maybe more complicated ones. Now these, when we're multiplying, we're going to multiply all these together. These are all these. This example, and this example are all going to be examples of rational expressions, but the expressions are just going to be, for this one, it's going to be numbers. So I've got 2 over 3 times 5 over 7. These are all, again, polynomials, because they can be called polynomials. These are typically numbers, though, but these are polynomials. So what do we do with 2 over 3 times 5 over 7? The long way around would be 2 times 5, because if we follow our definition of what we had before, 2 over 5 times 3 over 7, and now we look to say this is prime factored, this is prime factored, this is prime factored, the 7 is prime factored. So all these polynomials are prime factored, and now we look to cancel things out. We can cancel factors. Factors are things that multiply together, or that are multiplied together. So we look and say, there's a 2 here. Does 2 cancel with a 3? No. Does 2 cancel with a 7? No, because 2 divided by 3 is not 1. So we can't cancel that out. 5 cancels with the 3? No, it doesn't. 5 cancels with the 7? No, it doesn't. So our answer has to be 2 times 5, 10, over 3 times 7, 21. Now, obviously, that's a pretty simple, straightforward multiplication, but we had to take our steps and make sure that we, if we needed to factor things out, we could have factored those out. Now let's take a look at this example here. Now essentially this example here that I will put into green, this example here in the green example is really not different from this one here. The only difference is we've got x's here, we've got y's, and we've got z's in this multiplication. So the long way around would be to say, well, I've got 2 times x times 5 times z over 3 times y times 7. And now we look to, because now we've listed all of our prime factors, 2 and x and 5 and z and 3 and y and 7. 2x and 5 and z are all in the numerator. 3 and y and 7 are all in the denominator. And now you look, because these are all multiplied together, 2 times x times 5 times z, 2 and x and 5 and z are all factors. And we can look to cancel some of these factors with these factors down here. 3 times y times 7. 3 and y and 7 are all factors. Now can we cancel any of these out? Does 2 cancel with 3 or y or 7? No. X with 3 or y or 7? No. 5 with 3 or y or 7? Z with 3 or y or 7? They don't cancel out because nothing cancels to 1. Nothing divides to 1. So essentially then that becomes 2 times x times 5 times z is 10 xz over 21y. And that would be our answer. But again, if we go the long way, we can factor, 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 and look to cancel factors. Because remember, factors are things that can cancel out. Factors are things that multiply together, and factors can cancel out. Now with this one up here, we'll go with the red example here. The red example here is going to be 15 fourteenths times 21 tenths. Well, if we go the long way, we've got to factor 15. 15 is 3 times 5. 21 is 3 times 7. There's our numerators. All these are numerator factors. 14 is 2 times 7, 10 is 2 times 5, and essentially we've just kind of rewritten everything in prime factorization. Later on, when we get to polynomials with variables, especially with variables, we'll have to factor things out like this. But now we could essentially say that now we have just one giant multiplication. Here's a multiplication as well. So now we've got one giant numerator, one giant denominator, and we can look to cancel factors. Now these are all prime factored, so we could say that these are all the factors here are listed 3 times 5 times 3 times 7, and now we can look to cancel any of these factors with the factors that are down here. Factors down here in the denominator are 2 and 7 and 2 and 5, because we factored these into prime factors. So does 3 cancel with anything down here? Does 3 divide by 3 down here? Nope. 5 can cancel with the 5 down here, because 5 divided by 5 is 1. 5 and 5 are both factors. They can cancel. Does 3? Well, we've checked 3 already. That doesn't there's no factor down here that's a 3. 7 divided by 7 is 1, and they are both factors, so they can be canceled. So then what do we have here? We can kind of take the long way around and say, well, 3 times 3 is my numerator, 2 times 2 is my denominator, and that gives me 9/4, and that would be my answer. Now the really long way around would be to say if we took 15 fourteenths and started down here and said, well, 15 fourteenths times 21 tenths is 15 times 21 is, let's see, 210, and another 100 is 310, 315. Over 140, well, we sure could do that, but then we'd have to say, well, 315 is, let's see, 5 times 100 and, shoot, 5 times, 61, nope, 63. Over 140 is 5 times, let's see, 28. And then, 5 and the 5 cancels out, and we've got 63 over 28, and then you look to find another factor out of that one, and that's, to be honest with you, this is kind of the long way. We would get to the same answer up here as down here, but it would be the long way, because now we've got 63. If we continue on, we've got 63 over 28. 63 over 28 is 7 times 9 over 7 times 4. 7 divided by 7 equals 7 is a factor. 7 is a factor, so they can cancel out. 7 divided by 7 is 1. And we get 9/4. But shoot, man, to be honest with you, that's really the long way. That's the long way. And it's long with numbers, and it's going to be even longer if we get things like x squared minus 1 or x squared plus 2x plus 1. And we've got to factor that out. If we multiply all those polynomials, that would really get a big polynomial here that we'd have to factor later on. So if we've got polynomials later, we're going to definitely want to leave them in as factored a form as possible. So here's our probably best way to do it is 15 is 3 times 5, 21 is 3 times 7. If we've got the smaller numbers or the smaller polynomials, factor those as much as you can because they're already factored. So don't multiply them together because that's really the long way. Don't do this. I don't recommend doing this. So let's take a look at some examples of polynomials. And before we go there, let's, I guess, maybe make the list of things that we should probably remember for the procedure to multiply rational expressions. So step number one, I guess, would be to factor the numerators and factor the denominators. And if we go back to our previous example, that's what we did here. We factored 15 into 3 times 5, factored 21 into 3 times 7, and 14 and 10 we factored. So that was our first step. Second step was to simplify the ratios of common factors to 1. This, in layman's terms, means cancel the factors. And remember that factors multiply. Factors are multiplied together. And that's going to be something that we'll need to remember, because we'll see later on that we can look to maybe cancel some things in error. So we'll need to remember that factors are things that multiply together. So if you're looking to set up your cheat sheet or your study guide, factors are things that multiply together. So step number 2 is simplify the ratios of common factors, cancel factors, is what step number 2 says. Step number 3 says multiply the remaining factors, whatever is left over, multiply the numerator, multiply the denominator, and get an answer. So let's go on to something that might be a little more challenging, let's say. So these are our last 3 multiplications. Let's see. So if I've got 5a squared b times 5a squared b over 2 times 6a over 10b, I guess my first step would be to factor things out. So I've got 5 times a times b over 2 times 6a, and we could call, in fact, instead of calling it 6, we should probably call it something different. We should call it 2 times 3 times a, because essentially we're factoring everything that's up here in our numerator, and we're factoring everything in the denominator as well. 10b factors to 2 times 5 times b. And now we can say, well, we've got all this stuff multiplied in our numerator, we've got all this stuff multiplied together in our denominator. We can make just one big numerator own one big denominator and say all these are factors multiplied together, all these in the denominator are factors multiplied together. And now step number 2 in our previous example, step number 2 said, so step number 1 was factor the numerators and denominators. We just did that. Now we simplify the ratios of common factors, or cancel factors. And remember that factors are things that multiply together. So now we look and cancel factors. 5 divided by 5 is 1. So those are both factors. They can cancel out. Are there any a's in the, we've got a's in the numerator, a's in the denominator? No, we don't have any. So do we have any b's? Yes, we've got b's up here in the numerator. B divided by b is 1. They're both factors. They can cancel. 2 divided by 2, they're both factors. They can cancel. 2 divided by 2 is 1. They can go away. And now, let's see, we've got a and 3 and a. There's no a's and there's no 3's in the denominator, so we've got nothing left to cancel. So we now multiply all of our numerator together. 3 times a times a times a is 3a cubed over 2. And there's our answer, 3a cubed over 2. Nothing else cancels, nothing else factors out, because nothing else cancels. So there's our answer. If we go to this one, here's our next example. Oh, hang on a second. Don't know what happened here. Let's go back here. Let's see. All right, so if I've got 7a over 3b times 15b over 14a squared. Well, let's factor it out. I got 7 times a over 3 times b times 15 is 3 times 5 times b, because we're going to prime factorization. 15 factors to 3 times 5. 14a squared factors to 14 is 2 times 7. A squared is a times a. And now we've got all these things multiplied together in my numerator. I can make it one big numerator because they're all multiplying together. These as well are multiplied together in a denominator. And now that we've got all of our factors, all of our prime factors in our numerator and all of our prime factors in our denominator, we can start canceling things out. Cancel out factors. 7 is a factor, a is a factor, 3 is a factor, 5 is a factor, b is a factor, because they're all multiplied together. So let's look for factors that cancel out. 7 divided by 7 is 1. 7 and 7 are both factors because 7 is multiplied by all these things down here. Let's see. A divided by A is 1. That goes away, or becomes 1. 3 divided by 3 is 1. B divided by B is 1. And now we have what's left over, 5 over 2A. And there's our answer. Alright, this gets a little trickier over here, so let's make this green. Alright. 4x minus 8. Well, we've got to go back to chapter, I think, the previous chapter, and we've got to say, chapter 6, we've got to say we've got to factor this 4x minus 8. 4x minus 8 factors to 4 times x minus 8. And if we're going to go to prime factorization, we'll call the 4 2 times 2. And then the denominator is x plus 6. Well, we've got x plus 6, and I'm going to say that that's x plus 6 times 1. Just to kind of reinforce the idea that x plus 6 is a factor, 1 is a factor as well, because 1 is multiplied by x plus 6. So x plus 6 is an entire factor. Let's go to our second fraction, x squared plus 6x. Well, we've got to factor something out of x squared plus 6. The common factor, the greatest common factor is x. And what's left over? X plus 6. And we can double check that. We can say x times x is x squared. X times positive 6 is plus 6x. So that's a good factorization. Divided by 2x is divided by 2 times x. And now we've got a factor, a factor. 2 is a factor, 2 is a factor. Here's our factors in our numerator. 2 times 2 times x minus 8. X minus 8 is a factor. X is a factor here, but x plus 6 is a factor over here. So that x is not a factor. That x is a factor. This x plus 6 is a factor because x plus 6 is being multiplied by x. So all these things are multiplied together. X plus 6 is a factor. X is a factor. So now let's make our big numerator and our big denominator. There's our big numerator and our big denominator because everything's multiplied together. And now we can start looking at canceling factors. Remember, we cancel factors. Cancel factors when the factors divide to 1. And remember that factors are things that are multiplied together. Factors are things that are multiplied together. So that'll be something that we really need to keep in mind. So let's go back up here and say, well, you know what? Here I've done my factorization. I've factored my numerator, factored my denominator, and now let's cancel out factors. 2 is a factor. 2 is a factor. 2 divided by 2 is 1. It goes away. Let's see. Is there another 2 down here? Here's a 2 in the numerator. 2 cancels out with anything down here. Nope. X minus 8 is a factor. X minus 8 is a factor. X is not a factor. X minus 8 is a factor. Are there any x minus 8s down here? Nope. Here's an x here. X is a factor because x is being multiplied by x plus 6. X is being multiplied by x minus 8. So x here is a factor. This x is a factor as well. So we can cancel that one with this one. But keep in mind that x does not cancel with that x because that x is part of x plus 6. X plus 6 is a factor. This x is a factor, so that x does not cancel with that x. But this x here does cancel with that x because they are factors. X divided by x is 1. They're factors. They can cancel. Here's an x plus 6. That x plus 6 cancels with that x plus 6 because they are factors. X plus 6 divided by x plus 6 is 1. Goes away. And now we've kind of canceled out things or eliminated factors. And we see what's left over. I got a 2 times x minus 8 all over. And what's left over? I guess nothing. Maybe a 1 because we've got a 1 as a factor. But essentially, if we're going to make it prettier, we'd call it 2 times x minus 8. And that would be my factor. And that would be my answer, 2 over x minus 8. Now, if you left it like that, it'd be okay. I mean, that would be okay. But this is prettier, 2 times x minus 8. All right. Any questions? Bring it to school today.